Carbonyl compound will be any type of compound that has a carbon connected to an oxygen. Usually it's connected by a double bond, and then because there's a double bond, you know, carbon has to bond to 4 things, right? So you'll be able to see that carbon will make a bond like that with whatever, right? So when we talk about carbonyl compounds, many might argue that carbonyl compounds are the most important functional group, and then the reason for that is because they make up a majority of the functional groups. So you need to know that when you talk about carbonyl compounds, they can be categorized in 2. So let me say CC for carbonyl compounds. They can be categorized in 2, like that. So the first group of carbonyl compounds are the ones we are calling aldehydes. The ones we are calling aldehydes and ketones. Aldehydes and ketones. And then the second group of carbonyl compounds are the ones we are calling carboxylic acids and their derivatives. So carboxylic acids and the derivatives. Right, so up to that point we're okay, right? So now when we talk about an aldehyde, what does it mean when you say an aldehyde? Okay, so let me go back. So we said when you have a let me say a carbonyl functional group, you have C, which is carbon, double bonded to an oxygen, and then whatever is there can be different depending on which functional group, right? So now when you talk about an aldehyde functional group will look like this. So you have your carbonyl functional group looking like this. So you have some ara group. The ara group can be anything, right? So I'll just say ara, and then you have a hydrogen. So we call such an aldehyde functional group. And then when we talk about ketones, how do ketones look like? Ketones will have an ara group, they'll have the carbonyl group, and then they'll also have another ara group. So the ara group could be the same ara group or it could be a different ara group, but typically this is what you will see. Apologies for the noise, I don't know what's really going on there. Okay, anyway, so let's continue. So the second group are the ones we call carboxylic acids and their derivatives. So the first structure I'll draw is that of a carboxylic acid. How do they look like? So you have some ara group, say ara, and then you have your carboxylic, you have your carbonyl functional group there, and then you have this. So we say this is a carboxylic acid, and then everything else will be a derivative of this. Let me show you. So if you had an ara connected to your group like that, if instead here you had an amine group, right? If you had an amine group, this becomes an amide. So that's the difference between an amine and an amide. Let me just show you. So whenever you have an ara group connected to an NH2, we call this an amine. And then whenever you have an ara group connected to a carbonyl functional group and then connected to an amine group, we call this an amide. So that's the difference. And then the next derivative we can talk about esters. So you have an ara group connected to the carbonyl, which will be connected to an oxygen and then connected to another ara group. It could be the same ara group, could be a different ara group. Yeah, and then the last derivative are the ones we call acyl halides. So acyl halides, how do they look like? So you have something like that. You have a halogen here. So this will be your 2 groups of carbonyl compounds. So you just need to know they are categorized in 2. You have the aldehyde, the ketones on one side, and then you also have your carboxylic acids and also the derivatives of carboxylic acids. The next thing we can talk about, we can discuss the types of reactions. So what reactions do you expect carbonyl compounds to undergo? So a majority of the chemical reactions that are allowed are dictated by the carbonyl functional group itself. So you need to know this carbonyl functional group because of the difference in electronegativity between oxygen and carbon, the bond tends to be polar. And then because of the polarity of the bond, it gives it an array of physical properties. For example, they tend to have a high boiling point, even more than alkanes, because alkanes are just carbon and hydrogen, right? And then another thing is the boiling point will increase as you increase the number of carbons. So there's a lot of chemical chemical and physical properties that can result as a result of this simple bond, right? But then now, what type of reactions are allowed? So essentially, in general, there are two types of reactions that are allowed. So the first type of reaction are the ones we call nucleophilic addition reactions. So the first types of reactions are the ones we call nucleophilic addition, and then the second type of reactions are the ones we call nucleophilic substitution reactions. Nucleophilic substitution reactions. So at this level, I'm sure you know what nucleophiles are. Yeah, so these are typically the reactions. So let me just put this into perspective for you. What does it mean when you say nucleophilic addition? It's exactly what you think it means. So you start with some compound that contains a carbonyl group. So you can pick any. So let me just, okay, for simplicity's sake, let me, I don't know, doesn't really matter. Okay, let me pick an amide. So if I was to choose an amide, I would say I would have some ara group connected to the carbonyl like that, and then I would have the amine group, right? So what are we saying? What we're saying is that when reacted with certain reagents, you can have a nucleophilic addition reaction. So now, what are these reagents that can from which you can get nucleophilic addition? So I'll give you three examples here. The first type of reagent are the ones we call Grignard reagents. These ones are very, very common in organic chemistry courses. And then the second one are the ones we call Gilman reagents. I hope it's visible. Gilman reagents, right? And okay, I think for the purpose of this video, we'll only stick to the two. And then I'll show you, or maybe let me just put it in. So let's say organolithium reagents. So these are the three examples of compounds that can react and then do a nucleophilic addition reaction. So let me give you an example. Suppose you had a Grignard reagent. So in the next video, we'll expand on that. But then suppose we had one that looked like this. So we have magnesium, and then we have our bromine functional group. So when these two react, one thing you'll be able to see is that this carbon carries a net negative charge. Because it carries a net negative charge, because it carries a net negative charge, it's capable of attacking this carbon here. Why is it attacking this carbon? So you'll be able to see that the oxygen here is electronegative. Therefore, it withdraws electron density, right? Because it withdraws electron density, you'll be able to see that a net positive charge will be left here. So this carbon, this carbanion, right, or carbanion, I don't know how you pronounce it, is capable of attacking this carbocation, right? And then when that happens, you have a product that will look like this. So the product will look like this. Okay, so I'll draw it in steps. The product will look like this. So that's your amine functional group. And then you have that. So 1, 2, 3. 1, 2, 3, right? Now, one thing I want you to be able to see is whenever we do this, this is bad, right? Because it creates a very unstable situation. Because the carbon is connected to how many things? 1, 2, 3, 4, 5, right? Carbon doesn't want to make 5 bonds. So the only solution is for the carbon to break this bond by giving a lone pair like that. So when that happens, what you'll be able to see is that the oxygen here will have a net negative charge, right? Because it has a net negative charge, it can attract the magnesium bromide, which has a net positive charge. So why are we saying that? Magnesium has a charge of +2, right? Bromine has a charge of -1. Subtract the two, the net charge is +1. That's what I was trying to say here. So this is what you form. And then one thing you'll be able to see is that if you were to add hydronium ions to this same reaction, one thing you'll be able to see is that one of the hydrogens can be used there. And then after being used there, you can form an alcohol. So the final product will look like this. Final product will look like this. So you have Ara1, you have that, you have an alcohol there because this bond broke, right? And then you have your amine group, and then you have your group like that. So now what's my point? My point is that carbonyl compounds can participate in nucleophilic addition. If you remember, look at the compound before, look at it after. We've added something. What have we added? We've added this propyl group. So that's what I was trying to say. So let me show you how a Gilman reagent can do the same thing. So let me give you the exact same example for uniformity, right? So we'll have that. We'll have our amine group there. And then this time, instead of reacting a Grignard reagent, instead this time we'll react this reagent. So whenever you see copper and lithium, this is a Gilman reagent. Right? So this is a Gilman reagent. So whenever you react these things, the mechanism is pretty much the same. So one thing you need to know is the only difference is the way a Gilman reagent is. It's in such a way that it has two functional groups. So you can have two methyl groups, two whatever, right? These groups will always be two. That's why I've put a 2 there. So now, one of them is reactive and the other one is not so reactive because the other one is tightly held. So this will be very important for the future type of reactions we'll be doing, but just keep that in mind. So now what can happen? So one of the methyl groups can be given to this compound. One thing you need to know is one of the methyl groups is a carbanion, right? Like we said before, a carbanion is negatively charged. And then this is electronegative, and then this is slightly positive, right? So this can attack there. And then what will you form? So it will look like this. It will look something like this. Okay, let me show it in steps. So it will look like this. That's your NH2. And then there you have your methyl group. Where did this methyl group? It came from there, right? And then the rest of your okay, then you have your oxygen there. But then you need to know, I've dashed this because the carbon here will be connected to 5 things. 1, 2, 3, 4, 5. That's bad, right? So what happens is this bond has to break. When the bond breaks, the oxygen is negative. And then because the oxygen is negative, one thing that will happen is that it will attract the rest of the compound. That's this portion connected to a methyl group, right? This portion. Same concept that happened that side. So one thing you'll be able to see is if you add some hydronium ions, one thing that will happen is protonation can occur, and then your final product will look like this. Same as before. So you have your Ara group attached there, that's your amine group there, your methyl group, and then you have your alcohol group. And then this group will leave. So this will be your final product. The same thing can also happen for organolithium compounds. So let me use the exact same example so you can get it. So let's do that. Suppose I react this, but this time when reacting, I'll use an organolithium. So it can be any alkane attached to lithium, right? When I do that, what will happen? Exactly the same mechanism. So one thing you need to know, this is slightly negative. So what will happen is that it can attack there. And then what will you produce? At the end of the day, you will have a product that will look like this. So let me dash this. Your oxygen is there. There's your NH2, right? And then because it attacked here, one thing you see is you see 1, 2, 3, 4. So you see 1, 2, 3, 4, right? 1, 2, 3, 4. Yeah, so this will join there. But that's bad because carbon is now connected to 5 things. So this bond has to break. When it breaks, oxygen has more lone pairs and then it becomes negative. So the negative can covalently attract lithium, right? I mean, ionically, it can attract a lithium, and then that will be your situation. Add a little bit of some hydronium ions, like we've been doing. You add some hydronium ions, and what you'll be able to see is that one of the hydrogens or protonation can occur, and then your final product will look like this. So you have your Ara group, you have your alcohol there that you've made, and then you have your, that will be your. So we call these examples of reactions, we call these reactions nucleophilic addition, because you are moving from one state to another state with more substituents, right? So this is nucleophilic.